Imagine a scenario in which the enormous detonation wasn't the start of everything. Imagine a scenario in which the making of our universe was simply one of endless enormous bangs and new universes are still being shaped out there today. Well, then we would have arrived at the interesting hypothesis of turbulent expansion and consequently at a proposal that has now been given new impulse by an unforeseen discovery made by the James Webb Telescope. Based on the information gathered, a group of specialists has even reached the conclusion that our grandiose world was just made by blending with another universe. A simple inquiry, a complicated discussion. Although the conversation about what really came before the enormous detonation appears to be pointless from the start, not all specialists settle on a straightforward answer of nothing. Anyway, this was not the case for a certain Stephen Hawking, which is why the genius who died in 2018 could be quoted as follows on this subject. The topic of what was before the enormous detonation is equally as silly as asking which direction is north of the North Pole, since time itself, as it were, started with the Big Bang. This is an event that cannot have been caused by anything or anyone. The laws of nature themselves let us know that the universe can come into being without the requirement for energy or a cause. So far, so clear. But then we should not forget that there are other famous physicists who take the inverse view. For instance, Michio Kaku is convinced that there was something prior to the Big Bang and that string theory could give us a detailed insight into the mysterious stage before the vast beginning. Einstein said that the universe is a sort of air bubble that is expanding. However, string theory expresses that there are different air bubbles out there, an entire bubble shower of universes. Also, assuming string theory's multiverse exists, we can also figure out what occurred before the Big Bang. The Big Bang was the crash or the parting of universes. String theory does indeed come up with some remarkable conclusions that sometimes test our powers of imagination. Essentially, it depends on the assumption that the crucial objects of physics are not point particles but one-dimensional strings, or, in other words, strings that are found within each molecule. Applied to a higher context, string theory, in turn, states that each possible world also exists, in the same way that life has unfolded in our universe. This was by no means a simple fortuitous situation but maybe an inevitable result. Later, among the endless universes out there, there must be one in which the laws of physics fit together so totally that life emerges. The quest for the start. Yet, whether there is only a single universe or an entire grandiose foam shower, how do we even know when and how the universe was made? Well, to understand this, we need to turn back the wheel of time to the 1920s. That was when space experts first understood that most far-off galaxies are moving away from us. Later, however, it became certain that it's not the galaxies that are traveling through space as they escape, but instead that space itself is continually growing. And when the masters had uncovered the extension of the universe, they were also able to look at it in reverse and finally calculate back to a place where the density of matter and energy is infinite, where spatial distances are zero. Therefore, they had arrived at the first singularity and, consequently, at the limit starting point from which matter, space, and time arose around 13.8 billion years ago, as per the cosmological standard model. Anyway, a stage happened following the Big Bang in which the universe extended at an irrationally fast rate. Exhaustively, specialists expect that the universe extended by a factor of 10 to the power of 30 to 10 to the power of 100 during this cosmological expansion, and that, mind you, in a time period that makes the blink of an eye seem like eternity. However, it should be noted at this point that we are still quite far from seeing all the foundation to this super-vast development. In fact, expansion still represents perhaps one of the biggest secrets in cosmology. It's still questioned today whether it really occurred at all. Anyway, allies of the expansion? Hypothesis expects that there was, or alternately is, a unique field that has altogether impacted the uninhibited development of the universe, the supposed inflat field. Contingent upon its state, this field causes the universe to expand, deteriorate, or sometimes grow at a strangely quick rate. And, assuming that the inflat field was in a false vacuum soon after the Big Bang, irregular quantum fluctuations, that is, minuscule irregular fluctuations in the values of the fundamental particle fields, might have made it change into a real vacuum or into another false vacuum with lower energy. To explain, a valid vacuum in this context refers to a region of space with minimal energy, which doesn't necessarily have to be zero. In fact, a real vacuum can well contain mass and energy. There just should be no state in which this region contains even less energy, because then it would be a false vacuum moved to an infinite setting. This means that the change of condition of the inflat field has set the expansion of the universe in motion. However, during its progress from one vacuum state to the next, the said field also produced energy in the form of radiation and matter, and, accordingly, essentially made its own brake pad that ended the inflationary development stage, allowing the universe to expand at a normal speed from that point on. Well, essentially, that is the generally held hypothesis, but there are specialists who disapprove of this established view. These include, for example, the American physicists Paul Steinhardt and Alexander Vilenkin, who, as early as the 1980s, set forward the proposal that cosmological expansion did not, in fact, come to a total halt. In simple terms, arbitrary quantum variations could also give rise to individual air bubbles in which the inflat field takes on the proper value to end expansion elsewhere. However, expansion would continue unabated with the opposite end, suggesting that what we commonly call the universe is, in fact, only an air bubble-shaped subspace in which our reality could unfold in a similar breath. Anyway, this hypothesis also involves another no less intriguing fact. Since, if that is the case, then there must also be different air bubbles in which other universes have formed. In this specific situation, the Big Bang would no longer be the exact start of everything, but only the start of the expansion halting in our large air bubble. As a matter of fact, in this model, there is no such thing as a start of everything at all. It is a sort of timeless expansion from which new universe bubbles repeatedly split off. Now, the question remains, has our universe been swallowed by another? One of the most prominent mysteries of modern space research was, in fact, recently affirmed by the James Webb Telescope. The stunning revelation stands as the equally amazing and startling end that our universe could, at any time, have impacted with such a universe bubble. First, the so-called Hubble constant essentially demonstrates the speed at which space is currently growing. If we decide the corresponding value using our theoretical models and the cosmic background radiation, we get a Hubble constant of 67 kilometers per second per megaparsec. However, when the development rate is decided using supernova red giants, gravitational lensing, and variable stars, the Hubble constant is suddenly 73 kilometers per second per megaparsec. This is a hazardous deviation, most definitely. Furthermore, it amounts to the fact that the universe is growing faster today than it should. This has, as of late, been confirmed once again by the James Webb Telescope. To check the data of the past for potential mistakes, Webb took a closer look at over 320 variable stars, referred to as Cepheids. In doing so, they provided evidence that the incredible inconsistency is, in fact, real. But how is that even possible? How could it be that our models simply don't match the real observations in space? Well, that's the very question, and some specialists believe that colorful particles or structures of dark energy and dark matter, which are totally obscure to us, are potentially hanging out there. However, the study recently published by Yen Amorn and Yuki Wabi in the Journal of Cosmology and Astroparticle Physics comes to a somewhat unique end. In reality, the accelerated expansion of the universe could be powered by the steady blending with different universes. But that is not all. According to the study's creators, the consolidation with the so-called baby universes could, in fact, better explain the collected data than the standard model. In their work, the researchers demonstrated in detail that the consolidation with other universes should increase the volume of our own, a situation that is seen by our measuring instruments as immense expansion. Furthermore, the scientists also determined the expansion rate that would result in this case, and found that their values eventually matched real observations in space better than our established theories. At the same time, the researchers also addressed the issue of cosmological expansion and matter-of-factly left the possibility of an inflat field behind. According to their hypothesis, the dramatic development burst of the early universe can be explained by the idea that our young universe was gobbled up by a larger mother universe at the time. Thus, It continued in the steps of its infinite mother and began to crash into and absorb other baby universes. But does this mean that the true foundation of the Big Bang and expansion has finally been revealed? Have we finally found the answer to the question of what was before the Big Bang? Well, not exactly. Regardless of whether this new hypothesis aligns with reality, it cannot explain how the corresponding mother universe was formed. If you like, the chain to the mysterious start would just have been extended. Eventually, only the future can show whether the current standard model or the baby universe hypothesis is more suited to explain the ongoing expansion of the universe. The ongoing development of our universe can be explained simply by your tapping on the subscribe button. We'll trust you click like and subscribe so you never miss another video from us again. We'll see you soon.